Hello and welcome to ATI 4448. In this session we will address product design. We will look at the value of creating the product design and the different tools or methods that can be used to assist in creating the proper design. Through history, it shows that organizations always used a distinct department for product development, and you'll see that that department is called production department or product and development department, with certain duties and responsibilities. While in the current organizations, they are concentrating more on team approach, where the development team has a cross-functional representation or representatives from all discipline or functions, which will assist in forward thinking and proper problem solving during the design phase, so you will minimize the errors or going back to the design and reiterating the design to make sure of the proper design. The research of product development should include manufacturability. In other words, could it be manufactured? We should look at the ability to manufacture that product. So what are the activities that's needed to improve the design and specification or specifications during that research? And this is what we'll be looking at during this chapter. But first, what are the benefits of knowing these activities? The benefits are reducing complexity of the product. So we will know from the initial design what are the changes needed, what are the best options that should be followed to produce the proper design. Product will be standardized and more consistent when we do that, when we follow certain standardization rule or standards or policies that's being implemented by the different organizations governing that product. The functional aspects of the product will improve, and the design process will be improved in addition to the safety associated with that product. Knowing the product will improve product maintainability. All these factors together will create a robust design with the least possible cost. The figure here shows the using of value engineering that looked at the design for this product and how to produce the same product with lower cost. For example, the bracket shown in figure 1 or in part 1 was made from a different material. As you can see, the color of the material is different, and was welded with screws and bullets. In the second design, the screw and bullet were eliminated, but still we had two parts, and those two parts were connected with some sort of like a screw or something that will connect them together. In the third design, again, we used another material. There is no screws, no nothing, and the top part is attached to the lower part without any problem, just welded directly to the bottom of it. The value of the first one was $3.50. We lowered it to $2, and in the third design we lowered it to 80 cents. So we could iterate the design using different material, using different even design specifications until we got the lowest cost, and that is the value engineering. When developing a product, there are certain issues that should be considered, such as robust design, a design to standards, and during product development we need to look at the different tools that can be used to assist in design iteration, such as computer aided tools like computer aided design and computer aided manufacturing, CAD and CAM. So those are issues that we need to look at in the production. Do we have the tools? Do we have the resources needed for that? And these software packages and tools actually can assist in developing the iteration of the product design as we saw before, and based on the feedback and testing, we can reiterate and minimize design variability and design problems. If needed, you can use other technologies and utilize any available resource, such as virtual reality technology or engineering, value engineering, like we did, to be able to analyze and steer the product towards better design, and even, if you would like, better environment friendly design. So what do we mean by robust design in this product or in this situation? Using the different tools and techniques, as we stated in the previous slide, will assist in designing a product in a way that has small variation in production or assembly, which do not adversely affect the product itself. So robust means we are minimizing the variation of the product during production and during assembly. The small variation that we have will lead to a lower cost and higher quality because of the consistency and following the standards and the certain procedures that we created for that product during the design. The products designed in easily segmented components, and that will add flexibility to both production and marketing, and will improve the abilities to satisfy customer requirements. With the current available technology and the ability to share design on a global level, we can use computer-aided software to create the design, share with the customer, collect their feedback, readjust the design as needed, then send it to production. So these design drawings will be used to prepare engineering documentation that will be even used for the future, for future designs and in the production, and could be used as part of the documentation that will be sent with the product to the end user, such as user manual or assembly manual or so on. Actually, with the current technology and sharing capabilities, you don't have to wait for the drawing to be mailed by the mail and received and then adjusted, or you will receive a feedback, then mailed again, and so on, back and forth many times until you get the final design. You just can share that design live on the spot using internet, maybe even video conferencing, and get the feedback on the spot, which will lead to a shorter development cycle and will improve the accuracy, since we don't have a misunderstanding by communicating through paper or through email. Actually, when you can talk to the people using video conferencing, you can get their feedback and get the right response. If you have any question, then you can ask, and if they have any question, they will ask you. And then by doing this and sharing the information, you will minimize inaccuracies, and you will increase consistency and quality of the product. In addition, it's lower cost. You don't have to, like I said, extend the period of production and mail it and mail the design and do many iterations, where you end up at the end with some kind of error that will affect your major design. By doing this, you are lowering the cost. Using the CAD will lead to design for manufacturing and assembly, which combines the design for ease of manufacture of the parts at the same time with the product or the design to assemble that product. In this case, product manufacturing or assembly problems can be solved during the design stage. The CAD design can be sent to a 3D printer or a machine, which will create a small prototype of the product that can be shared with customers or investors. Actually, for your product in this semester, you will have the ability to use either AutoCAD or SolidWorks to design it, then print it on a 3D printer. And we have in the ATC, we have two 3D printers. We have a AutoCAD lab where they will assist you in creating your design and then printing it on the 3D printer. Now remember, if you want to do that, you have to do it early in the semester, because at the end of the semester many groups will be doing that, and the printing will take about 19 hours just to print one item. So make sure to do your prototype as soon as possible. As we said before, the designs created through the CAD drawing, it can be shared on a global level, but within the ISO standard for the exchange of product model data, which is called STEP. So sharing is available globally, and you can send the drawings, send the design, and then adjust it as needed and then print it. But always you have to follow certain standards. Once the design is completed, you can utilize computer software to control machine in the manufacturing workspace. Computers can be also used to assist in the operations in the manufacturing plant, including the planning, managing, logistics, and inventory of that product and its parts. CAM is a subsequent process after CAD. The generated design in CAD will be an input to the CAM software that will operate and run the machines in the manufacturing facility. The benefits of having a computer-aided design that could be input in a computer-aided manufacturing software is the ability to produce higher quality products. And that will also shorten the time of the design. In addition, it will reduce the cost of production. The drawings and documentation will be available in the database for future references and analysis. So for the CAD and CAM designs, they added a new range of capabilities for not only the design process but also for the manufacturing side of the product. We can use also another way to show the product or to look at the design of the product, which is called virtual reality. and that's another technology that can create a simulated environment which can simulate the actual presence of the product. It allows people to see the finished design before a physical model is built. The virtual reality is very effective in large-scale designs such as plant layout, building designs, office space design, houses. They use it all the time, and that will give you an impression, or that will give you an actual look at that design before it's physically built and before spending lots of money on the actual product. As was shown in a previous slide with the item that was value engineered, you can see that value engineering focuses on design improvement during the production. And usually these improvements are seeking better design or lower cost of the product. We managed to lower the cost from $3.50 to 80 cents only. And that's by iterating the design using different material, using different maybe welding, connection, or other parts for the product. That will be all for this session. If you have any questions, you can use any of the communication channels that is provided for you. Thank you and have a great day.